Alright, so this video is about the Three Stone Tensor. Now, the first thing we want to know is when there's a light beam, right? When there's a light beam that's coming from a source, right, then its speed is c and the source speed is 0, and it's 0 to c. When that light beam reflects off of an object that's out there, the same thing happens. Its speed is 0 and the light is c coming from it. That's in an independently relative state. Now, as the light comes back, then there's a change in frequency, right? That's related to speed. And speed is distance over time. That frequency is related to time, right? So frequency is related to time. So when we're dealing, now this is a reflector and this is an emitter, right? So when we're dealing with the Three Stone Tensor, we have the object planet A, right? And it's going to be emitting some light. Now object planet B, right? And it's going to be emitting some light. And the ship is moving between the two. So we want to know what the relationship is, right, between the relative speed of the ship to the speed of light coming from planet A. And that's given by mc squared over 1 minus the square root of v squared over c squared, right? And then we want to do the same thing from this side. So what is the relationship of the ship to the speed of light coming from planet B? That's v to c, and that is also mc squared over 1 minus the square root of v squared over c squared. Right? And so this is the warp space, right? When this goes to an extreme frequency like this, it becomes matter. Okay? M equals, okay, E, it becomes matter. E equals mc squared. And it has gravity. It has gravity. And it has gravity even way before it has matter. Okay? So this is the warp space, right? So this gives you, this part of the tensor gives you the warp space behind the ship, and this part of the tensor gives you the warp space in front of the ship. And this part, since the ship is going in this direction, this part is obviously a lot higher frequency than the departure part. But this tensor is using both of these, and then to come up with the calculation for what is happening to the ship, we use the following operator. This part of the tensor minus this part of the tensor equals 0 to C for the ship. So the ship has a consistent speed, a consistent stasis speed of 0 to C, no matter what speed it's going.